Welcome, everyone. Thanks for coming. It's now 1, so we'll go ahead and get started on the event. My name is Jane McClintock. I'm an energy engineer at the Smart Energy Design Assistance Center here at the University of Illinois, CDAC, and I'll be hosting our event today. We are super excited to have wonderful panelists on and to have you all here to join us for this conversation about commercial energy code, bringing together perspectives from code officials, architects, and contractors. I'm honored and excited to be joined by these 4 amazing panelists with profound and varied experience with all stages of building and design and construction. So many thanks to the panelists for joining us today. And thank you all for joining us, all of the participants for joining on. This event's all about your questions. So I want to encourage you to put your questions in the Q&A box window on your Zoom screen. It should be down at the bottom, kind of in the center, Q&A. And we will try to move the questions that we're currently answering over to the chat, so you can keep an eye on that and follow along. We also wanted to let everyone know that we will be recording the event to make it available on our website, so you can watch it at your leisure. And please expect a certificate of completion for your participation coming in your email in the next couple of days. And with that housekeeping, I will quickly introduce CDAC and our energy code resources and our program sponsor, and then turn it over to our wonderful panelists to introduce themselves. So CDAC is the Smart Energy Design Assistance Center. And as I mentioned, we're an applied research program of the University of Illinois. Our goal is to reduce the energy footprint of Illinois and beyond. And one of the ways we do that is by being the Illinois Energy Code training provider. And this training is funded by the Illinois State Energy Office. So we want to thank the IEPA and the State Energy Office for making this training available today. We also do some other energy code training resources. And so we wanted to let you know about our technical support lines. We have a 1-800 number, but also an email hotline that you can always ask your questions. And then on our website, which is smartenergy.illinois.edu, we have a variety of resources available on demand, which are past workshops and webinars, and then on-demand online courses. So you can get continuing education credits from those online courses. We'll have a new one up about compliance paths this week. And yes, some other frequently asked questions and useful websites, and also those hotlines. We also have some upcoming events, which we'll send out the links to register for these in the upcoming days. So keep an eye out for those. We're going to be looking at ComCheck and ResCheck, and then we thought it would be interesting for folks to talk about ASHRAE 90.1 and how it differs. So we're going to have an event on envelope and then mechanical, comparing ASHRAE to IECC. So stay tuned for those. And as always, if you have any questions in the future, don't hesitate to reach out. We're here to help. But today, you can ask your questions to our amazing panelists. So please don't forget to put your questions in the Q&A. And I will pass it to the panelists to introduce themselves. Jill, would you be up for introducing yourself first and tell us a little bit about what you do and how your work interfaces with energy efficiency and energy code?
Sure. Hi, everyone. I am Jill Dykman. I work at Premier Engineers, which is an engineering architecture firm in Chicago. And I lead up the architectural group, doing full service projects to renovations and beyond. Sustainability is tied in there, and we also do the code reviews for the city of Chicago. So I see the energy code day in, day out in everything that I do.
Awesome. Thanks, Jill. Thanks for being here.
Mm-hmm.
And going in on my screen, Chris, could you introduce yourself?
Sure, Jane, thanks. I'm Chris Schwadick. I'm the chief code consultant at Burnham Nationwide, which is a 30-year-old company in the permit expediting field. I'm the director of the code group, which is a licensed architectural subsidiary of Burnham that I assisted in founding back in 2001. Over the past 2 decades, I've gone through many code reviews for the city of Chicago and for other municipalities, as well as consulting with numerous developers, architects, owners, property managers, contractors. In addition, I am an adjunct at Harper College and have taught a course on building codes since 1998. I'm also currently a member of the Long-Term Code Development Process Committee for the International Code Council Board of Directors, and also serve as the chair of the Compliance Code Action Committee, specifically reviewing methods for accreditation of third-party certification agencies. My other professional affiliations include the American Institute of Architects. I'm the secretary of the AIA Chicago Foundation Board, and I was the 2018 chair of the National AIA Codes and Standards Committee.
Fantastic.
Thanks.
Thank you. Corey?
Yes, good afternoon. My name is Corey Zussman. I'm a director of quality at Pepper Construction, large construction company in Chicago. We deal with commercial, residential, multifamily, high-rise, municipal, pretty much almost any construction type. I am a licensed architect. I practiced for about 15 years before I went to the contracting side, where I've been working for a little over 15 years. I deal heavily in the energy requirements, building envelope requirements, as well as fire and some interior flooring and items like that. That's all I got.
Great. Thanks for being here. Appreciate it. And Allison?
All right, I'm Allison Mcsherry. I'm a licensed architect with Klein & Hoffman, and we kind of have two areas of expertise. One is the repair and restoration of existing building envelopes. So go out, hang out on the side of buildings, figure out what's wrong and how to fix it. As well as on the new construction side, we do building envelope commissioning as well as peer review. And how I got involved in the energy code to begin with was right out of college, which was kind of the recession. I found myself at an MEP engineering firm doing 100% energy modeling for both 179D tax deductions as well as LEED. So that's how I really got involved in the energy code, and still doing it to this day. As well as actually in the past, for 3 cycle years, I taught energy code compliance through energy modeling through the DCO BITE grant. So CDAC's taken over that teaching component of that. So I was able to go around the state of Illinois and talk to engineers, architects, code officials, building owners about how to use energy modeling for code compliance.
Oh, that's awesome. Well, great. Thank you all for being here, because this is an amazing panel, as everyone can see. And I would like to start it off with one question, and then we'll jump into the questions that are coming into the Q&A. But I just want to remind folks, don't be shy, add some questions. We'll try to get to all of them. I thought could we warm things up by asking, do you guys have a kind of general question? Do you have any recommendations or best practices or lessons learned about collaboration between designers, construction folks, contractors, and code officials? And you all have a little bit of experience in a lot of these. So your experience spans these different areas of building, design, and construction. So I think you'll be well positioned to say, how can we better collaborate, or what are we doing that's working well? What are our areas to grow?
I could start it off by just being able to be working in an engineering company. Pre-pandemic, it was a little bit easier. You just get up and you walk over to whomever's desk and you hash the items out. Post-pandemic, it will be interesting how it continues, if it's team meetings, Zoom meetings, but there's been a lot of just interaction internal with the different engineers to assure compliance. Being that I also do some code reviews, I sometimes know what they're looking for and making sure all the documentation's there to show it, but trying to get everything on the drawings the best that we can.
So I would agree with, trying to get all the information on the drawings and the specifications, making sure that any Any alternates meet those specifications as well. We see a lot of, for example, window specifications where the basis of design meets the intent of the energy model, but some of the other products do not. So getting all the information, making sure that we have a conversation and getting the right information on the drawings and specifications are extremely helpful.
Yeah, I think just good communication in general, getting all the players to the board at the very beginning to understand what is the intent. So it might start with the OPR, where does the owner know enough to know what they need in an OPR? Again, are you making just a code minimum building? We're doing prescriptive on everything. It's a little less crucial that, everyone's talking from the very beginning, but if we're trying to do a high performance building and we are using a performance cap with an energy model, we seem to know from the start what are our goals. Is everyone designing to that same goal? And we'll probably get into it later, but I see very often, the architects using IUPC, the MEPs using ASHRAE. We don't even know exactly what path we're following. It's kind of up in the air, and that can create some major issues down the line. So just getting everyone on the same page from the start.
Yeah, I have to agree with all of that. I think communication has to exist on many different levels, right? Because as architects and engineers, there is a way of communicating graphically with the construction drawings as well as with the specifications. But what you provide to a building code official, or for that matter to an owner, may be necessarily different, and in some cases needs to be addressed in a different way than you would normally provide. I've seen many situations where clients didn't understand what the requirements were because it wasn't really communicated properly. I've seen code officials that weren't clear on what was being communicated on the drawings because something was left out that may have been in the spec book, was never included as part of the permit submittals. So there's a lot of issues related to that, and it's just a matter of reminding yourself who it is you're communicating with and what it is you need to address.
Great. So I think we'll come back to a lot of these themes throughout this conversation, but making sure that everything's there and that communication starts early is coming out to me. We have a couple questions that have come in about lighting. So I'd say let's start with lighting. One is about retrofit. So retrofitting of LED lights in existing buildings. How common is lighting control upgrades like occupancy sensors, time switch controls, where a facility does an LED upgrade? What aspects make these controls likely? Have you seen controls being added in retrofits? Not a specific requirement, but
I think it all depends on the owner too, of what they're looking for at the end.
yeah, and
I always defer to our lighting designer on these questions because that's what they deal with day in and day out.
So it's a matter of what triggers the need to alter those, right? Because in a commercial office building, for example, you're constantly turning over space. Although, again, post-pandemic, we don't know exactly how that environment is going to be adjusting to the new norm. But yeah, so it's definitely something that needs to be addressed, not only for commercial but for residential purposes now too, because with each iteration of the code, we keep upping those requirements. But and the number of light fixtures that you touch used to be at a 50% level, and now it's much less than that. So even in smaller alterations, the need arises to upgrade those systems.
Oh, great. Yeah, and there's a lot we can talk about with renovations. Yeah, we have a question about ComCheck now that's come in. If you use ComCheck, does the 30% maximum fenestration area apply? Can ComCheck be a compliance path that can allow you to put in more fenestration area?
ComCheck does allow for the trade-off path where you can make some trade-offs. However, if you look at the minimum values for your opaque wall assembly versus what you can achieve even with high performance windows, you're basically never going to be able to really get that trade-off. So that's, again, something, the biggest thing that in my experience the trigger for what code path you're going down is going to be your window wall ratio. So 30%, that's an IACC requirement. ASHRAE at the very beginning, you get up to 40. IACC, you can go up to 40. However, you have to have very detailed daylighting controls that often aren't realistic based on the footprint of your building and the layout of your floors. So in my experience, if you are going over more than 1% or 2%, you're really going to want to look at the performance path. And again, it comes back down to what are you trying to do? Are you trying to bake just code minimum, which again, I think we've said in some previous talks, that's legally the worst building you're allowed to make. It's not, this high bar that everyone should strive to. It's legally the worst building you're allowed to make. So if you are doing, a one-off that isn't, you may not have control of the building for a long time, and okay, maybe that is appropriate, but you have to ask yourself the question of why is that the path you want to go down? Can you just reduce your window wall ratio, or do you have to go down a more detailed prescriptive or performance path?
We have a question that came in that is a little bit more general. What are the benefits of doing an energy model or following the prescriptive path? So Allison has touched on this, but do others have comments on kind of what are the benefits of taking that performance path approach, or what are kind of the pros and cons that you find to various paths to compliance more generally?
I can speak on it again, but if anyone else wants to jump in, go ahead. Just because this happens to be kind of my area of expertise. I would say for most buildings, if again their goal is minimum code compliance, you in general always want to do the prescriptive path unless you have some special design feature. Again, my focus is on the envelope. So say you have a really fancy atrium, or you want to do a really large skylight that's outside of that, that may trip that trigger to require you to do a performance path. However, if you're using the energy model performance path as just a energy code compliance check, kind of a big expensive paperweight that you may not pass in the end. So if you are wanting to go down the energy modeling path, we always say early and often, you want to start in pre-design, schematic design. Can we optimize window to wall ratio? Can we optimize orientation? Can we make these upgrades to the envelope that will then allow your HVAC designers to even have a different system? This happens a lot with, office buildings. If you have better envelope, you can get away from perimeter heating, those types of things. So as a code compliance path, I would never say yes to an energy model. But if you use the energy model as a tool to make a better, more efficient building, and that happens to show your compliance path, that's great. And for example, where we've seen this happen a few times is I was working on a hotel in Colorado, and they were doing a PACE financing, which required you to be 15% above the energy code minimally in order to get this different path of financing. And so just at the start, it was a goal that the envelopes, the HVAC, and the lighting each were supposed to be 15% above the code. And if we just looked at code minimum with like a little bit better improvement, we were looking at 4 inches of continuous insulation. They had a lot of different claddings on it. There was brick, stone, different things. Through early energy modeling, we were able to say that there was a less than 1% energy savings going from 2 inches of continuous to 4 inches. So now we've saved that material, but more importantly, we've saved difficult connections that also are thermal bridges. So those are the types of values that you get with energy modeling. And that's when I would recommend it, is really, use it throughout the entire design process, not just as a compliance tool when everything's already done.
Great, thanks, Allison. That's a great example. And I don't know, we have a comment in the chat that's a little difficult to hear your microphone. If you can make yourself a little bit louder, I'm not sure if there's easy fix. But thank you for that wisdom. We have a question about continuous insulation and slab edges. So let me jump to a more specific envelope question while we're on the envelope. Regarding energy code and continuous insulation, many projects that are required to have continuous insulation do not seem to insulate below the slab edge. We often see the exterior continuous insulation stop at the bottom of the wall, at the wall finish, and at the interior side of the foundation wall, 4 foot below the slab and 4 foot horizontal under the slab. Do code officials flag this, and what is the preferred way to execute this detail? I'm kind of looking at you, Corey, because I know this was a topic you wanted to talk about, but anyone who wants to pick it up.
I did. So the I know the IECC 2018 shows some diagrams of the preferred method for insulation, and the insulation for a long time now has been required to go to the top of the slab. So we see this all the time on drawings that they don't show that. So we do bring it up. We do recommend going all the way to the top of the slab per code. But we either cover it with the wall, overhang the wall a little bit, or we'll cant the insulation. So it goes at a 45 or a 75 degree angle at the top. So there's only about 3/4 of an inch or less that's shown of insulation at the top of the slab. That seems to take care of it. We don't have cracking issues. We don't have problems with the floor when we do that. Anybody else?
You know, this is a question that comes up for us a lot, is detailing that edge.
Yeah, so we also see it on the outside of the building, and then typically we'll put a stainless steel shroud over the insulation to protect it. So it's either inside or outside. We'll have that detail.
Nice.
So unlike a lot of the requirements for fire resistance ratings, where you have a lot of studies and tests, data, all that, you really don't have a lot of that in the energy field. Doesn't really address a lot of those concerns. So you kind of have to make it up. And if there are people in the building department who have tried to address some of those issues with architects and engineers, it's helpful, but it doesn't necessarily then translate to other jurisdictions as well. So, but yeah, I think that the inspectors sometimes miss things like that, just like they do anything else. And it's really a matter of how much diligence is involved in both the architect and the contractor coming to terms with what it is they need to do. And it sounds like where you've had that happen successfully. So that's good.
Great. And we have a question about mechanical systems, which is kind of jumping from envelope, but is on insulating mechanical systems. Can anyone speak to the benefits of a good insulated mechanical system to insulating pipes and ducts? And I don't know if that's something that is a requirement, but I'm not sure if we've quantified that or see the benefits in energy models.
I can't really speak to it because again, I'm really focused on envelope, but I will know in the energy modeling building world, it's generally something that isn't looked at. There are, depending on the software you're using, there are some duct loss and other things that you can factor in, but it's generally not part of the typical procedure.
Okay. And then someone asked a question about energy modeling. How are these reviewed? So to what level of detail are code energy models reviewed? Is it similar to the lead energy model review process? This is something that maybe the plan reviewers could speak to. Are the energy models reviewed by the code officials?
We review them by looking at them and making sure they're compliant and pass. I don't know how other firms are doing it or how the city's doing it. That's just internally, we make sure what's modeled is actually on the drawings also. Because sometimes what's modeled is not always what is on the drawings. And with the permit submittal, we don't get the specifications. So it could be something that's in a spec and not on the drawings also.
And so I agree with Jill. We actually ask for the energy model or the contract or if it's prescriptive because we want to make sure that we're installing what the intended product was supposed to be. So like I said before, we don't always choose the basis of design. We'll choose a different product, what's in the spec, and that might not meet what was intended in the energy code or energy model. So we will ask for that just for what Jill mentioned. We want to make sure that the owner is getting what they expect.
Mm-hmm.
Well, I think the energy model is treated much the same way any kind of engineering judgment is treated. The code official is going to look at it, understand who prepared it, and what software was used and that kind of thing, and whether or not it looks reasonable. But they're not going to go through every little detail in regards to it. Is that right? Most people's experience, I would think that would be true.
Yeah, and that's definitely a major source of inconsistencies across jurisdictions as far as, you know, how knowledgeable the code officials are with that. I know in the past, I've been asked to answer questions where a code official knew that something seemed off about the model, but didn't know what. So I'm sure CDAC, probably now that you are the person to go to for questions on the energy code, has probably received some of those. So it depends on what you're given and the what the code official understands about it. But again, minimally does this match up, because I've definitely seen models that are nothing like what's on the drawing.
Right, and unlike the ComCheck, which we're all familiar with from 20 years, and know what to look for, and know how to spot check it, models can be wildly different depending on what it is that they're trying to achieve, and they're not modeling everything, so that there are other components there too that need to be addressed. But it also, I think, has to do with the priority in which a particular building department or code official is looking at these things. If it's at a high priority, they're going to take more time with it. If it's a low priority, it's not going to be addressed.
Yeah, certainly we find that some building departments are spread thin, so it's have to prioritize what they look at in the review. We have this maybe kind of is a good follow-up, because we talk about how the basis of design document might change, and so we want to know what's actually being modeled is what is in the actual drawings. So maybe this leads into how important is a complete basis of design document to share the intent with all participants in the project. Should the basis of design be required by code? And then we have a comment in the chat about just highlighting what Allison said in terms of the owner's project requirements and how important it is to be on the same page with goals from the beginning of the project. How important are these documents in terms of setting expectations early?
So as a contractor, both these documents are extremely important. Again, to make sure that we're bidding appropriately, and the owner and the architect are getting what they anticipate. Having the OPR and having that part of our repertoire of information really helps us make sure that we don't veer off. And as far as getting a basis of design information of all the products that they intended for the model, for example, it's super critical. I mean, that gives us the right information at the right time. So I would love if it was a code requirement because we don't always get that.
I fully agree with Corey. I think it's really crucial, and I'm not really designing new systems, but in the role as envelope commissioning or peer review, understanding what the intent was from the beginning is crucial. But particularly as a modeler, why it's really important is when VE starts to come in. I've been on projects where they were going for lead, they had a certain level they wanted to achieve, they assumed a certain amount of points for that energy model, and then they VE'd every single energy saving measure that there was and thought, okay, well, why am I not getting my points? So again, having a document that everyone has seen from the very beginning becomes very important to get the product that you want in the end.
Yeah, like you just mentioned, the VE, that document would create a stoplight, right? Because if it doesn't meet those requirements, then it's a non-starter, and everybody on the job would always know it, whether if the job changed leadership or not, right? So I agree with that.
Well, great. Yeah, that seems like strong emphasis on what we started out with, which is the importance of early communication and clear goal setting. So can we jump back to a more specific envelope question? And this is, what are some best practices you observe to limit thermal bridging in the envelope? And then we have a related question if you want to answer them both at once or take them separately. But what are some options for attaching cladding that don't interrupt the continuous insulation?
This can go a lot of different directions. I think Corey is also thinking about how to answer this one.
Yeah, I mean, it's a big question. Apologies for that.
Question, but coming from the high level, we see this most often with window detailing, where they will have a continuous metal piece going interior to exterior, one giant thermal bridge. You're always going to get condensation. So something at a minimum that we recommend is doing therm modeling for all your typical, not all, but your typical window details. So if you have one typical window, you do a head, jam, sill, and see where that is. That will very easily and pretty quickly and cost effectively say, okay, I have a problem. Once you start getting to the attachment systems, maybe Corey can speak a little bit more to this, but there are some different options, but they do have cost implications. And again, it gets back to what level of building do you want? And I know I need to comb through the newest codes that have been released. There was some talk about trying to get a point system for thermal bridges. Currently, they're not addressed in the codes. And as far as energy modeling goes, they're also not addressed beyond studs. So if you have stud with cavity insulation and continuous insulation, you do downregulate that cavity insulation to account for the thermal bridging that happens through the metal studs. However, attachment system for cladding is not accounted
So yeah, so we actually ask for therm models too as well, because we've learned that when we don't and we have issues with our windows, one of the first issues comes back to the contractor. So we do try and flag things and make sure that that's been looked at. Like you said, any through wall metal, anything that goes from the cold side to the warm side is definitely an issue. As far as attachments go, there's lots of different types of attachments out there. There are other issues, however. So Certain types of insulation require mechanically fastening to the substrate, which is going to be a thermal short as well. It's more than just the attachment of the cladding that becomes a potential concern. So the holistic approach of what is going to need to be attached, what's going to go from hot to cold, that needs to be looked at. And again, there's just a plethora of materials out there, fiberglass, rubber, just plastic. There's just lots of different ways to address it. But just know that it's more than just cladding attachment that needs to be addressed.
I actually have a question for Corey. And it's on a broad sense of things. With the whole supply chain issue that's out there and raw materials, on the construction side, do you see more items being VE'd energy-wise, or just a switch in general materials, just due to what we're dealing with these days?
So we are seeing material shortages, like I'm sure everybody is. A few of the main insulations are of big concern. So mineral wool. So we're seeing switches from a mineral wool to a different material, both inside the cavity and outside the cavity, which poses some issues. Roof insulation has been the latest one. A lot of our jobs can't see roof insulation until November. So that makes us switch to a different type of insulation. So from a polyiso, we're switching to an EPS, which has its ups and downs. But there are things that we need to consider. Yeah, we're seeing it. We're seeing it in sealant. We're seeing it in a whole bunch of stuff. But specifically for energy, we're seeing it in insulation in two different fields right now. It's crazy.
Well, it's not just the shortages too, right? It's the cost. I mean,
Well, so the cost, see so the cost, the only thing that we're really seeing skyrocket that we have no choice is wood, right? We're seeing a lot of the wood. Everyone has a meme about how much wood costs. But the insulation, we're actually seeing shortages. So we're not able to get it. Sometimes not able to get drywall in certain locations either. But I've got 3 or 4 projects that we had to switch to EPS, not because of the cost, which we have switched to EPS because of the cost, but we are switching because we can't get polyiso in time to close our building up. We're seeing some air barriers having supply issues, and I'm not sure if that's because of what happened in Texas, but we're seeing that as well, and having to switch air barriers because of material shortages rather than cost.
so a lot of times what we see too when they're doing these kind of switches between what was approved in the building department and what is actually being built have to do with the difference between trying to get a good energy efficient wall and then also maintain the fire resistance rating. A lot of and sometimes that happens a lot, during the plan reviews as well, because they run into issues related to NFPA 285, and the fact that there's a myriad of ways to put these things together, and only so many can be tested. So that's a whole other school of thought that has to exist, which goes back to communication, which goes back to it wasn't that long ago that fire protection engineers and energy people just didn't communicate very well, and they didn't have enough understanding really of how that works. And then you see things like Grenfell. So it's definitely important to be able to adjust those things accordingly when you have shortages and that kind of thing. But then also remember, it concerns me when you say mineral wool is there's a shortage and you're substituting another material that may not necessarily meet that fire criteria. So yeah, it's definitely part of the reality we live in right now, is to deal with all that. Gee.
Yeah, that's definitely conversations that we've had, especially when we've had the change out of interval. It's not just flick of the switch. Let's just use polyiso under a certain material or XPS, right? So yeah, no, that's in it, and that actually goes back to the basis of design documents. I mean, keeping everyone in line with what the original intent was. But yeah, I can't comment enough about an FPA 285 and how it is not easy to make switches.
Yeah, thanks, Jill, for the timely question. We have a question that came in about documentation, which we haven't really touched on. So maybe we could jump over to how to document compliance. Is there any advantage to documenting compliance in plan drawings versus the specification manual, or conditional on what is being documented? So is it feasible to document compliance in one location in the plan documents? This might be one that the plan reviewers could speak to.
Yeah, well, the first rule is that duplication leads to contradiction. So if you're trying to do the same information in more than one location, inevitably you're going to have a problem, right? And it goes back to what I was saying about, you know, communicating with a code official as opposed to communicating to a contractor. Contractors prefer looking at the project manual and specifications and all that, because that's what they're using as part of their pricing, and you know, go back to it day in and day out. Code officials typically don't see that, and so they need to have those things on the drawings. Fortunately, a few iterations ago, the energy code did specify what the minimum information was supposed to be on the drawings in chapter 1. And that is very helpful. But that, again, is a minimum thing that, you know, in many cases is even missed. More so even in Chicago, because if you're looking at the energy chapter, that information isn't in it. They moved it to the administrative portion of the code. So rather than be in the energy code portion, it's an administrative. And so unless you know that, if you're looking at, say, the Illinois version, that is basically what the model code says, then you know where it's located. But if you didn't, you'd have no clue unless you understood how the code was formatted and organized. So, and even then, you know, it's a little bit of a challenge to address because you have, in many cases, municipalities, and certainly in Chicago, in addition to your ComCheck or ResCheck, you've got a form that you need to fill out that indicates, you know, what compliance path you're going, and, you know, whether you're using IECC or ASHRAE or what you're doing, right? And and if that is filled out correctly, usually it's whatever is necessary for the code official to see. But then it's, I think, also helpful to have on the drawings not only that information, but within the context of the details. I mean, how often do you see this where, you know, they will actually indicate the U values and R values, and that sort of thing is integrated with the other information that's part of the construction drawings. So yeah, there's so much that one can accomplish, I guess, in the code compliance field, but it is certainly something that has been tried to be addressed anyway over the years, and I don't think it's quite there yet.
I would agree with Chris. And yes, we don't see the specifications. And if we comment on certain items, they'll say, well, it's in the project manual. So we're sort of taking the designer's word for it, since we don't see that. Sometimes we do ask for the specification just to make sure. But I'm not seeing a lot of energy requirements on the permit documentation. It's a challenge to get it on to the permit drawings.
Yes, this is a topic that I know in past SUDAC roundtables and kind of within the community, we've discussed that it would be really nice to have one sheet in your drawing set that goes through everything. I guess New York City has a pretty robust thing that does this. We've looked into, what would this entail, but it really requires the buy-in of the entire design community. It would be more work. You would have to get, what is that standard? And like we mentioned, it does create the potential conflict between the specifications where a lot of this is dictated in the drawing. So we're just not there yet.
Yeah, this is a conversation we hear from architects a lot. Is there a contractor perspective that you'd share on this, Corey, in terms of what kind of drawings might be most useful to you, or how could it be best organized?
So, I mean, having it in one location would be ideal. We constantly see the different specifications versus the drawings. So that causes conflict. One of the things that I would really love to see in the drawings, honestly, is air barrier and vapor barrier locations. I clearly identified on the drawings, on both the plan and the sections, and so without question, would be able to identify if there's any breaks or any concerns that we have to deal with, or if we have like a garage that we need to have air barrier roll on the inside of the building, for example. If we can get that into the code, that'd be very helpful. But like everyone else, really having it in one location would be best.
Well, I'll say this about the one location business, because for many years, and of course, the accessibility requirements in the code have predated, most of what we do with energy these days. And many firms have what I would call a cheat sheet of accessibility requirements. And they have put the entire A117.1 on one page and said, this is compliant, right? And then you start looking at the drawings and you see where all the inconsistencies lie. So I wouldn't necessarily say that that's a good thing, is to have this, cheat sheet approach. I do think that going through and organizing a document that both summarizes those requirements and then tells you where in the drawings to look to find them is the best approach, because that way you have a way of relating the two in such a way that you can actually find it.
Yeah, that's a very good idea, Chris. I would agree. I mean, yes, that would be great, is identifying where we can find that information in the drawings.
Kind of an index, but no shortcut to having it, checking it in the actual drawings. That's wonderful. And then, we have a question that is back to a little bit more of a general idea we've touched upon, but could you speak a little bit more about how can we sell energy efficiency upgrades? How can we share with our clients the benefits of going beyond code compliance? And that's maybe back to some of what's the value of doing prescriptive path, but how do we convince the clients of that value, or is that a challenge for our clients interested?
I know Pepper, we have a rather large sustainability department that we've developed tools to show the owner the benefits of doing certain things, adding more insulation, changing the type of windows, changing the type of HVAC systems or lighting. So we created these tools to express to the owner the benefit. I know that we're not the only ones that have these tools. I think those tools exist outside, and I mean those tools are extremely helpful in explaining the benefit of going beyond code as a life of the building sort of design.
Yeah, I would say it really comes down to educating the owner. You know, how much do they know about energy efficiency? Are they only looking at a simple payback? Are they going to own the building for more than a year, or are they flipping it? And so they really don't care if, you know, the energy bills are higher. What, again, is kind of their baseline knowledge, because from the envelope side of things and working on restorations, where we do sometimes, because of failure, have to do, you know, full window replacements, they're great to have an energy upgrade, but they will never ever pay for themselves. So, you know, our mantra is definitely the envelope is meant to be on the building for the longest. You want to make sure you do that right. But again, if you do that right, then your options for HVAC and lighting open up to things that may not have been possible if you were only doing a code minimum building, which again could compound savings on top of it. So it's really about educating the owner and understanding, you know, what it is, what metrics they're looking at to make that decision.
And I know on some of our CDB jobs that if the more energy efficient your larger systems are, the more energy rebates and incentives that you can achieve. And the state's always looking for incentives and rebates on projects. So it's a catch-22 of, you know, you're playing the game of costs and implications, but it is out there and it is a requirement on state projects at least.
Do you all see folks using the energy modeling to take advantage of utility incentives?
Yeah, we will. That's one of the things our department does is, you know, we'll research, you know, all of the rebate options and opportunities and then present that to the owner. So absolutely.
So that may be another way to sell people on above code and, you know, help to finance some of those upgrades too.
Yeah, and I know there's definitely facilitators within the utility program, so we'll help you do that. Some people offer things for free. They can get you in contact, so at least get the idea. And now, at least in Chicago and a few other areas in Illinois, there is the PACE funding, which is not free money, but it's an alternate financing path that could open up opportunities, but a requirement of that is being energy efficient, making energy efficient either upgrades or beyond code designs for new buildings.
Yeah, and part of what our job is, I think, is to let people know that those kind of things exist, that there are incentives out there, and these are the you know, the options you have. But yeah, it's definitely a challenge to be able to you know, play these numbers and to understand, you know, if you do this, it will have benefits that are built upon something else that's happening, and then you can you know, benefit from that as well. But it's not something you can just talk about. You actually have to prove it. And so I think that you know, a great deal then is part of the process is to just be able to have the tools to be able to do that effectively, and not just, you know, shrug it off too, because it's I think necessary to address from you know, if you're talking about energy compliance issues and you're not talking about efficiencies, then what are you talking about? It's just, oh, I have to meet code, right? Well, okay, but then there's other things involved in that probably would be a benefit to know.
Kind of back to those early conversations and communication, but following up on this, when do you all see these conversations happening? Are these discussions of efficiency and trying to quantify that for the clients? Does that happen early on when clients are establishing goals for the project?
So at Pepper, we like to have that conversation as early as possible because it's going to affect price. So as soon as we're able to get the job and help with pre-construction, that's when we'll start our sustainability department on that task. It's all about cost in the end. So the earlier the better.
Mm-hmm.
And with the incentives and rebates, pretty much once we decide what the major equipments are in play, we'll reach out to some of the utility companies to see where we're at and, you know, what steps forward we'll need to take in our designs.
As soon as possible. And then we have a question, is there energy per square foot that you're seeing on projects? As we're getting better tools to, educating clients, how good are buildings getting? What kind of energy per square foot do you see? And is there a discussion of approaching net zero in commercial buildings? Maybe it's a hard question.
Yeah, I can't answer what I'm seeing on buildings, and then it gets into the question, is that a modeled number or is that an actual verified number? Because to let you in on a dirty little secret of energy modeling, at best, they predict that energy models are about within 20% of the actual, and that's for a variety of reasons. I don't want to scare you, but one is weather. We use typical meteorological years, which is a weather average over 30 years. We all know with climate change, our weather has wildly different patterns. The other is occupant use. We have to assume many things for a model, and we all know the issues with assuming. So there can be a wild, so that. I will say that I've been to, energy modeling conferences and other things, and the talk is still to approach net zero. That is the goal eventually of the code. Now, realistically, at least in our area, I don't see that necessarily happening anytime soon. I know California is very aggressive on that. They are planning to reach net zero relatively soon in both the residential and commercial sector. So that is still the ultimate goal. But obviously in areas where our electricity and gas are not nearly as expensive, there's less incentive to be as aggressive with programs that get you to net zero.
So in terms of net zero, the 2021 IECC has appendices, one for residential and one for commercial. That is, as an appendix is optional. So a municipality can adopt it. It'll be interesting to see whether the state adopts it and what kind of discussions will ensue as a result of that. But I do also know that just recently, I believe at the beginning of the month, the city of Chicago announced that they formed a task force to look into that issue specifically, trying to address zero code. So that has just gotten underway. So and the zero code appendix that's in the IECC was generated by the 2030 people. So, and of course, 2030 is not that far away. So, but the idea of it, and of course, the impetus for this is coming from the local officials. Okay, this is not something that you're hearing out of Washington, and that is an important thing to consider too. Is that the more that can be done in terms of advocating for these things and to address them not only for new construction, but for existing buildings as well. I mean, it's the reason why we have a benchmarking ordinance in Chicago and in other cities, is to try to at least get people aware of these kind of issues and how they need to be addressed. But electrification of buildings, I think, is also on their list of things to address, as well as renewables and innovation and building design and new construction. So all those things are over and above what we're dealing with in the building department, and yet there are people who can influence this process and make sure that we're dealing with something that is going to be of the most benefit.
Yeah, not going to be easy to get there, but we're on our way. We have another question about sort of the current times, kind of following on Jill's question about supply chain, and but in other ways, in terms of how buildings are being constructed, maybe ventilation. How has COVID impacted what you're seeing in building designs? And of course, it's a sort of an open-ended question. Maybe we touched on work from home too. That maybe a lot of it's unknown at this point. But do you see any trends or anticipate anything from COVID-19?
I haven't specifically had designs impacted, but I know there's been a lot of talk specifically with, yes, ventilation, but also humidification. So I haven't seen that people are necessarily wanting to add humidification, but they want it maybe to be an option as like an add-on later. So, typically it's only in kind of the healthcare realm and very specialized areas do we see active humidification. So that's an area that I definitely see being impacted, as well as, again, moving towards more of the DOAS system that you can really control ventilation and separating out from the space conditioning component of that. But as far as, offices and all of that, I have not seen anything yet.
Oh, and then we have, going back to lighting, we have a comment that per the IECC, the 2018 IECC, if more than 10% of the lighting is updated, the controls need to be updated as well, which I think is probably what the first asker, the person who originally asked was getting at, is that doesn't always happen. We certainly see a lot of LED retrofits where that doesn't happen, but it is, people have confirmed it is a requirement. So I apologize for misspeaking. Uncommon, but it should be happening. And then let me see. Well, I guess we have a very common question in all formats, but that has come up here again. What about roof repairs and recovers? When are you required to bring the roof to compliance with the energy code? And do you have any experiences where there might have been challenges or kind of a gray area on roof repairs or replacements?
Yeah, that's a difficult one because even when you're doing repairs, you sometimes have to go down to the sheathing. And so, yeah. And then what good is it if you're just replacing a certain portion of it to meet energy code and the rest of it is just there as it was. So that's always a challenge. And then also when you're dealing with insulation and parapets, right, or curbs and that kind of thing, and trying to meet the values that you're trying to meet, but you can't do it because it's going to be difficult retrofit for some buildings. So that is definitely a challenge. But certainly, a tear off obviously is going to be new, and then it's really a matter of what the code official is looking for in terms of what they need as far as a permit, right? Because if it's just doing repairs, sometimes they don't even need a permit, right? They just need to be cognizant of where the line is drawn in terms of repairs. And so, yeah, it is almost a case-by-case thing where you're dealing with that.
With roofs, I think the biggest thing that we've encountered, because we do so many existing buildings, is again the technical infeasibility, as Chris was saying, with existing curbs, existing parapet heights, door heights, etc. Chicago did add that into theirs, where basically you used to have to get a technical infeasibility variance, whereas now it's just written in the code because they recognize that. But again, once you start getting into partial repairs, etc., it gets really dicey, and you have to look at a case-by-case basis.
And what about Allison? This might be a follow-up question for you. What about adding insulation to envelopes during repairs? When an envelope needs to be replaced, is there a requirement, or is it common for insulation to be upgraded?
So it kind of depends. It's one of those things where, again, if you open up the cavity, in most cases, the cavities are required to be filled. So you wouldn't be required to upgrade the whole wall, where now the requirement is cavity plus continuous. You're not required to remove the cladding, etc. And so that's very often where if you open it up, you have to do it. Now you then start getting into, well, if you have an existing masonry wall and you decide to build it out, what do you do now? Because you can't meet the new wall requirements with cavity insulation alone. So what do you do? And again, that's a very specific case-by-case basis. And it also gets into more of the building science aspect, where if you're insulating a building that was never meant to be insulated, are you now creating moisture issues? So that's something that is critical, is evaluated in that. The same goes where if you're doing new windows. So if you're doing new windows, the new windows have to meet the energy code. But if you're putting it into an existing opening, how is that going to change the relationship? And are you going to start having condensation issues? So once again, therm modeling is recommended in those instances.
And following up on the comments about how things might go wrong, and we talked a little bit about detailing air barriers and demonstrating that there aren't gaps. Could we share, go around and share maybe some of the most common errors that we see? Like where do we see problems in terms of some of those difficult connection points or details in envelope? I know parapets have come up, but.
So I'll start. One of the bigger ones that we see are the connection to the windows. So they're connecting to the wrong sealant line. They're not connecting to the window primary as identified by the manufacturer. We'll see a connection between the roof and the air barrier, but not the right materials. We'll see that as the waterproofing too. So, we won't have a compatible material making that connection. Or when we'll see a lack of connection to an existing building at the right location. So, for example, if a roof is getting corrected or redone, and it's going against an existing wall that has a cavity, no one's closing up that cavity, for example. So we'll still have an air barrier issue right between those two. So my biggest things are windows, of course, the parapets, and waterproofing is what we're seeing.
Yeah, I would just reiterate that. Basically, any transition and any different trade, because it can become unclear who's responsible for what. And then you're in the field and kind of, oh, they were supposed to do this. Now it's not my responsibility. I didn't price this. Or so again, the wall to your roof, parapets are notoriously bad. You need to make sure that's fully evaluated. The windows, below grade to above grade, even that can be tricky in some instances. So you really just want to pay attention to those transitions and make sure that everyone understands what their responsibility is.
And with that, making sure that the transitions are given to a trade that knows how to install the transition. So just because the roofer is going to be there first, it might not be the best idea to give him the transition because he doesn't truly know how to install that product, for example. So keep that in mind as well. And actually, what keeps coming up are window connections to the air barrier. If it's not a sealant joint, and if it's a pre-cured silicone, for example, or maybe an expansion joint material, but the window guys won't do it unless they're forced to with a gun sometimes. But understanding who's going to do that and when it's going to be done is important to get on the drawings and understanding of that.
I'm hearing more need for communication and coordination early.
Yeah, because again, the contractor, not all contractors, but some contractors will choose to do that transition by the cheapest guy, right? So is the air barrier guy going to be cheaper than the roofer, or the roofer going to be cheaper? And again, that may not be the best person to use.
I think that, unless there's another question, may be a good transition. We had, in our little session prior to this, we had talked about, upcoming code things. And as far as air barrier goes, the next iteration, IECC is going to require air barrier testing for all buildings, basically. ASHRAE, I just looked it up. That is an option. However, you're able to get out of it if you essentially do building envelope commissioning light, which means you have a qualified third party review your details, make comments, and do periodic site visits. So that is hopefully something that is going to be kind of remedied by these. But again, it comes down to, you want to make sure you're doing it right and don't find out after the fact that you're not passing for some reason.
Yeah, air barrier tests are always too late, right? It's really hard to manage. That's a tough one. But I agree, having someone look at your drawings and being there periodically, I guess more than periodically, it needs to be defined, because periodically could be twice, right?
Exactly, yeah. The ASHRAE doesn't have a lot of teeth in that requirement, but as far as things to look forward to, as far as OPRs and what's required, understanding that that is a decision that will take you down either the IECC or ASHRAE path up front is very important, because if you have a large building, doing whole building area barrier testing, when it actually makes a difference, can be a nightmare. And what season are you in? Are you, how are you sequencing the building? Do you have to, block off all the HVAC? Like there's a lot of really logistically difficult, but also costly implications where, again, more value may be in that kind of envelope commissioning role. But again, you may want to define that because the code leaves it really open for interpretation.
I would agree.
Yeah, I'm glad you brought that up, Allison, because it's kind of an emerging place in commercial buildings. It's something we have a lot of experience with on the residential side, and we're still saying, hey, we should do this earlier and earlier to be able to learn from it as we're, before we put up drywall. So, yeah, are there common issues that that you all see with air barrier issues in commercial buildings? The one that we often see is above a dropped ceiling, that there's no air barrier. So remembering that even that acoustical ceiling is not an air barrier can sometimes be missed.
The location of the air barrier, even though the code allows you to place it anywhere, it really needs to be thought of very carefully if it's being placed on the interior. and how that's actually connecting. What's the life of that? Who actually touches it? Um, Placing the air barrier on the wrong side of a thermal wall is also sometimes problematic, because if the air barrier is on the warm or cold side in the winter, that interior air moisture is going to get through and hit the air barrier at the wrong temperature. So that also needs to be looked at.
Well, great. Does anybody have any sort of parting thoughts, maybe in terms of what can we do to collaborate? What are our hopes for moving forward into a new code? So as things, as we have that ultimate goal of net zero, we know we're going to be stepping into a new energy code here soon. How can we step up collaboration to meet these new challenges towards our ultimate sustainability goals?
That's a huge question, but I think the first piece of it is education. So having things like this where, again, as architects, you're responsible for a lot of different things, a lot of different codes. The codes are always changing. It's really hard to stay on top of it. Same thing goes with ownership, where again, they really need to be educated on, what are they getting? What do they actually want? Do they need some hand holding as far as developing their OPR, all of those different types of things? Because there's a lot of moving parts. There just definitely is. And without that education, pieces are still going to be missed. But I think Chris's idea of like an index is genius as far as, because what it forces you to do is a lot of times, you look at IUCC, a minimum requirement is an area weighted U value average and solar heat gain coefficient. I have never in my life ever seen that on a document. Most people don't even know what their window wall ratio. So having an index where you have to point to where that's located would really point out where there are some gaps in designs. Like it would not be perfect, but it would be a great starting point. And again, it would make reviewers, contractors, it would make everyone's job easier if there was one place to go to point to where that information is located.
Well, and education has its limitations too, right? Because the way things evolved over decades, really, you had plan examiners in building departments who were former tradespeople. They were actually out there building what it is they're now looking at drawings of. So they have that more comprehensive experience of being able to equate what is on the drawings, which, as opposed to what their experience has been as far as building goes. But you don't have that anymore. You don't have a lot of tradespeople who are actually out in the field building this stuff and understanding what the problems are from a contractor point of view or from a supplier's point of view, how all that works. And so all they can go by is what they're trained to do. And the training is really about what the code says and how to interpret it. It's not about how, this issue of working out the details between, disparate materials goes or anything like that. There's no real good references to that other than people's experience. So, yeah, it is. It's definitely a challenge, and unless you have champions really to address that from a enforcement perspective and from a code perspective, it's going to continue to be a gap in terms of communication. And so maybe the training involves things like actually viewing a video, for example, of how this stuff goes together. You can learn a lot just from watching how something gets built, as opposed to, find this in chapter 5 or look at, this particular definition to see what it means. It has its good points, but it also has its limitations. And I think that to a certain degree, if you don't get that buy-in, we're kind of left on our own, you know, from an architect's perspective to deal with. And then it's who do you trust? You know, what kind of consultants you use and how they can be best utilized. Because again, you know, budgets are what they are, and you can't just, you know, spend all your money on consulting fees too. So it's yeah, definitely going to be a challenge. I mean, the other thing that we're going to be looking at past 2021 is the fact that the IECC will not be written as a code anymore, in terms of how the process works. I mean, it'll still resemble what we see today, but the process will be different in that there will be less outside involvement and more, you know, expertise that is, well, good, but it can also be inbred, so that, you know, you're going to see very similar parallels to what's going on, you know, in the sustainability code, where, you know, IEC or the ICC basically dropped their idea of writing a green code, right? They're just using 189. Will that happen with the energy code? And that's, you know, something for future speculation, I guess. But yeah, I think that the efforts involved in meeting these requirements, and it's great that, you know, governmental bodies are behind this and all that, but it was one of the reasons why ICC decided that they were going to switch gears and do a standard approach as opposed to the code approach that they were using before. So yeah, there's a lot of definitely interesting developments that are occur over the next several years.
And going back to what Allison said, I think, you know, get out in front at the beginning of everything and, you know, hash things out, big ideas, owner, engineer, architect. And then once you do submit for the permit side of it, try documenting it the best you can on the drawings that are being reviewed. And then that will go down to the contractor side of it actually getting built the way that is intended. Full circle.
Well, great. I think if anyone else want to comment, or I really appreciate all these thoughts. I think that it's, you know, it's not easy to collaborate and coordinate early, but you know, that's what is needed on many levels to get these details done right, is what, you know, what we're hearing today, I think. So
And real quick, this is kind of getting more into the energy modeling side, but it comes back to early decisions. And I haven't looked at the specific requirement in the 2021, but in 2018, if you are doing a performance path, so an energy model for IECC, you don't just have to be the same or better than code. You have to be at least 15% better than code. That is often something that's missed because it's not in the chapter that talks about the energy model. It's in the very beginning where it talks about what paths you can do. So you can either do ASHRAE, prescriptive, or performance, which again, in my experience, you're doing a performance path because you have some deficiencies. So to make up for that deficiency and then be 50% on top of that, essentially is never going to happen. So if you are considering having to use the performance-based path, you need to let the whole team know that you have to go to ASHRAE, because that has some other things. There's the sub-metering and monitoring that ASHRAE requires, receptacle switching that ASHRAE requires. You know, there are some differences that all designers and entities need to be aware of early on. So you do need to be on the same page from the beginning.
Great. Yeah, that's a good point. And we look forward to talking a lot about those differences in our upcoming ASHRAE versus IACC talks. So we'll get into the nitty gritty on that. If people are interested, keep a lookout for the registration links for those webinars. Well, thank you all for coming today, and thank you for the excellent questions and just the wonderful insights on how to move forward, and also just how to get these details right. So I really appreciate everyone's time today and sharing your expertise and your questions and thoughts with us.
You.
Thank you.
Thank you.
Have a wonderful rest of the day.